This lesson is covering some material out of Unit 3-4, Box A. We're taking an introduction to polynomials. What we want to be able to do by the end of this lesson is to classify polynomials based on the number of terms that they have and identify coefficients and constant terms. So where we're going to start here is we're just going to remind ourselves what a term is. And we looked at terms in the last lesson, and we said that a term might be something like this was a term, okay? And we talked about what the parts of it were. We said that this number that we had out in front was the coefficient. This letter that we saw in here was sort of the variable part. And this number, which usually appeared up on top of the variable, was our familiar exponent. And what this meant is that we were taking 8 and we were multiplying it by x cubed. So a series of things that are all multiplied together form a single term. Now we can have a term that has no coefficient. We could just see something like, I don't know, y to the power of 8 or something like that. When we don't see a number out front, when we don't see a coefficient, what do we assume that coefficient is out in front? We assume that there is a 1 there. And we usually don't write it, but I'll just put it in brackets like this in a different color. So we assume that there's a 1 there if we don't see the coefficient. We can also have a term with no variable part to it. That would just be something like, I don't know, -3. Okay, where it's just a coefficient and no variable. And because there's no variable, because there's no thing that can change, if we change what the value of the variable is, we call something like this a constant term. Because no matter what happens, this always represents -3. Okay, whereas this over here, y to the power of 8, can represent different things depending on what we decide the value of y is going to be when we sub it in. Okay? So we've got terms. We can have terms with no coefficients. We can have terms with no variables that are called constant terms. Now, if we take a bunch of terms and we connect them together using addition or subtraction, we got what we called an expression. Another name for that is a polynomial. Okay? And this is where we get to introduction to polynomials. Polynomials are simply expressions with one or more terms. They can have 1, they can have 2, they can have 3, they can have 4, they can have 5. They can have any number of terms that you want. So you take a bunch of terms, connect them together with addition and subtraction, and you get a polynomial. The only thing that has to be true about these things is that the exponents on these variables must be positive whole numbers. So I've got 3 examples right here of polynomials. The first one here is 3x squared. This has 1 term in it. And if a polynomial only has 1 term in it, we give it a special name. We call it a monomial. Okay? Mono meaning 1, and meal meaning I have no idea what the meal means. I guess it comes from polynomial, right? So a monomial only has 1 term. Next one down here, 4y squared minus 8 has 2 terms in it. Okay. If it has 2 terms in it, we call it a binomial. Okay? Bi meaning 2. Just like bicycle or I don't know what else. Next one down, we have, well, how many terms do we have here in this next one here? We got 3 terms. So 3 terms. What do you think we call a 3-term polynomial? We're no longer a trinomial. Yeah, like tricycle, 3 wheels on a tricycle. Okay? And anything that has more than that 4 terms, 5 terms, we usually just call it a polynomial. We kind of give up on the special names and we just say, oh, that's a polynomial. Poly just meaning many, many terms to it. Okay? So in these polynomials, we got 3 of them here. Do any of them have a constant term in them? What do you think, Chris? Yeah, 8. Okay, and we'll actually think of it as -8. Okay, because we'll think of this sign here as always going with the term that it comes in front of. So I'll say -8. Are there any other constant terms in any of these? Yeah, this +12 are constant terms. Now, so those are all examples of polynomials. At the bottom here, I have 2 examples of things that are not polynomials. Okay? Why are these things not polynomials? Yeah. The exponent here is a negative number. Okay? So the exponents in polynomials have to be positive, and down here our exponent is not a whole number. So if the exponents are negative or not whole numbers, we do not have polynomials. Okay? And that's it for box A.